Well, good evening. Welcome to Logos Research Associates live stream broadcast. My name is Jay Siegert. I'm the president of Logos Research Associates, also the founding director of the Starting Point Project, and I have the privilege of being the host for this evening's presentation. For those of you who are somewhat new to Logos Research Associates, I'll give you a little bit of background. Logos Research Associates is a fellowship of scholars and scientists that are committed to upholding a high view of science and a high view of Scripture. We sincerely believe that the scholarship, logic, and the scientific method can and should be used to show that the Bible's historical claims are both credible and ultimately superior to the secular model of origins. Logos sponsors many creation research initiatives and projects involving many different experts and scientific disciplines, all working towards a goal of increasing the explanatory power of the biblical creation model of origins and Earth history. The goal of this live stream series is to provide you with the opportunity to hear from top researchers who will convey cutting-edge scientific evidence for the Genesis creation account. Just before I introduce our speaker for this evening, I just want to open up with a quick word of prayer. Dear Heavenly Father, we just thank you so much for these opportunities to be discussing things about your amazing creation, ultimately to get to know you better. We thank you for all the brilliant minds of the past who have done so much research to bring us to where we are today. And we thank you for those who are around today that you have greatly gifted to do further research and also help explain things to others so that ultimately we're better positioned to share the gospel message of Jesus Christ. We certainly look forward to getting to know you as our creator, but even more personally as our savior. So we thank you for these times and pray all these things in Jesus' name. Amen. I now have the privilege of introducing our speaker for this evening, Spike Psarris. He has a bachelor's of science in electrical engineering from the University of Massachusetts. He's also done graduate work in physics. He's also worked for a number of years for the United States military space program. It's pretty cool. He entered that program, he tells us, as an atheist and committed evolutionist, and left as a creationist and strong Christian. So his testimony is kind of fascinating. He now speaks and writes on science, creation, and the Bible, and he's a producer of an amazing video series entitled What You Aren't Being Told About Astronomy. And I just happen to have one right here. You can't read it so well, but this is the third in his series of three. He's working on some new stuff too, but the third in the series focuses on the Big Bang. It's one of my favorites. I think I've seen it 3 times. I actually watched a little bit more of it a few days ago. Also, you can visit him at his website, creationastronomy.com. That's creationastronomy.com to see other resources and articles that he's written. I'd highly recommend checking out his resources. He'll tell you more about that a little bit later. But with that, Spike, welcome to the broadcast.
Thanks for having me, Jay. My privilege to be here. And hello to everyone watching.
Since you responded, I'm assuming you can hear and see me. So basically the format of tonight's presentation, turning it over to Spike. He's going to give his presentation. You could be submitting questions along the way. When he's finished, we will turn it over to doing Q&A. We'll cover as many questions as we can in a certain period of time. So be thinking about your questions, submit them in the chat, and then we'll cover what we can when we're done. So with that, Spike, I'll turn it over to you.
Thank you very much, Jay. And I assume, there we go. Now my slides are showing. Well, hello, everyone. As you can see, our topic this evening, creation in the heavens, perceiving God's glory through astronomy. We're now in our second year of these live webinars for Logos Research Associates, for which I'm an ambassador, by the way. I should mention that. This is, however, the first one we're doing on astronomy. So this will be a sort of an overview of the subject and the various things that could be delved into deeper. If there's enough interest, maybe we can have some more in-depth sessions on specific areas of astronomy later. But tonight will be, as I said, an overview of how we can perceive creation through this science. Now, typically in a presentation, I would start by introducing myself, but Jay just did that. I am an engineer. I did work in the military space program, and I am a former atheist, atheist and evolutionist. I was an atheist because I was an evolutionist. I understood that science showed how everything got here without a creator. And so why would you want to believe in one anyway? And it wasn't until working in the military side of the space program that I was confronted with evidence against my evolutionism and therefore my atheism. And after struggling with that for quite some time and trying actually to disprove it, was forced to change my worldview. So I left that program as a creationist and a Christian. And the transformation happened in that order. I became a creationist first because of the evidence, and that then opened the door to becoming a Christian. And I like to mention that when I speak, because a lot of times in the creation evolution debate, people present the creation side as us being creationists because we have to. Because we have this pre-commitment to the Bible as being true, that then puts these blinders of faith on us, and it prevents us from seeing all the evidence from science. And that if we could take off these blinders, then we would see all the evidence for the millions of years and Darwinian processes and all the rest of it. Well, I'm one of many for whom the opposite is true. I became convinced by the evidence first that creation was true. Now, believing in creation, of course, is not sufficient to make one a Christian. I mean, there are Muslims who are creationists, right? But this is the stumbling block for many, as it was for me. And so this is why this is one of my passions now, is talking about the subject and presenting a different perspective to people than what is usually presented in the media. As Jay mentioned, I have produced a video series on these sorts of topics. Much of what you'll hear tonight is based on these videos. So those of you who have seen the videos, I've seen a few comments in the chat already. Some of this will be repeat material for you. I hope you don't mind, but I think it's worth talking about anyway. So our subject tonight, creation of the heavens, perceiving God's glory through astronomy. Now, of course, there's so much we could talk about with astronomy, and one of the main benefits of doing so, from my perspective, is that there's all these beautiful things we can show. And as you'll see in my presentation, there's going to be a lot of beautiful visuals, a lot of beautiful objects. Unfortunately, my face is going to be on the screen sometimes too, which will cancel some of that beauty and reduce the overall attractiveness of the presentation, but you got to work with what you have, right? But the Bible does tell us that the heavens declare the glory of God. Now, this makes astronomy unique in all of the sciences in that it contains a promise. We are promised that if we do a diligent study of the heavens, that we will be rewarded with a better perception, a better appreciation for God's glory. And I think that's amazing. But the question is, how exactly do the heavens declare the glory of God? Well, if you ask people about this, you usually get one of two answers, sometimes both at the same time. The common one that most people would say, well, the size and the scale of the universe, the cosmos is so immense that tells us of God's majesty and power as the creator. And that's true. Other people will say, well, the beauty that we see in all of these various objects, Saturn, Jupiter, amazing things that we see not only in our solar system, but throughout the whole cosmos, tells us of God's abilities as an artist. And so we're learning more about the Lord's characteristics in that sense. However, when it comes to origins, neither of these is really all that helpful, because if somebody is approaching this with a secular mindset, they would say, well, yeah, the cosmos is immense. That's because the Big Bang made an immense universe. And what is beauty anyway? Beauty is just subjective thing. We just happen to appreciate things, but it's just really different arrangements of molecules. So what? So if we're going to talk about someone and the origins implications of astronomy, we need something a little more specific and a little more relatable. So in my time tonight, I'm going to ask the question, if the universe were created, which of course it was, what would we expect to see? How would we be able to tell that the universe was created? Well, I'm going to argue that there's at least three things we would expect. Number one, we would expect to see evidence for youth. As we're looking at these objects, if they were indeed created recently, we would expect at least some of them to look that way. We wouldn't expect them to evidence to show evidence for billions of years and so on. We would also see evidence for design. If they're just the outcome of the laws of physics working over time, they would look one way. I mean, things assembling at random, basically. But if they were created and designed, we would expect to see evidence of that. Lastly, this one's a little more amorphous, but you'll see what I mean by this later. We would hopefully see evidence for creation itself. We would expect to see some kind of stamp, if you will, some sort of proof of God's handiwork, perhaps in a sense, a message that he is sending to us through the heavens. And you'll see what I mean by that at the end, because we're going to take these in order. We're going to start with evidence for youth. When we look at all these various objects in the cosmos, how old are they? Well, that's actually not a simple question to answer, and it's not as straightforward as you might think, because it's largely driven by the assumptions that you bring to the table when you answer the question. What do I mean by that? Well, let's take a specific example, our sun. How old is the sun? Well, if you look it up, you'll be told that it's billions of years old. And the people who saying that are deriving that number from an assumption that the sun formed from a cloud of gas using or according to models of stellar formation. And indeed, if the sun did come from a cloud of gas, then it would take several billion years to go through the various stages of stellar evolution to turn into the object that we see today. But you're assuming that it came from a cloud of gas in order to make that conclusion. Well, if the Bible is true, then the sun didn't come from a cloud of gas slowly forming through natural processes. The Lord created a mature sun on day 4 for the purpose of sustaining life on earth and to be the greater light to rule the day. So we would expect to see a mature sun, which is what we see, but it's not billions of years old after all. So you see, depending on the assumption that you bring to your analysis, you're going to reach a different conclusion. So this situation applies to a lot of things within astronomy where assumptions are ultimately determining your conclusion. So let's look something a little more concrete example and some more closely observable processes within our own solar system, because the solar system is where our planet is. So we have had the opportunity to examine many of these objects in much greater detail. Do we see processes at work in the planets and moons in our solar system that would indicate they're not actually billions of years old? And the answer is yes. We'll talk about a couple of them here tonight. The first is planetary magnetism. For example, the Earth. This is the magnetic field that we study the most closely because we live within it. We know that the Earth has a magnetic field because, number one, compasses work, and number two, you can witness its effect in other ways, such as seeing auroras if the conditions are right. So the Earth has a magnetic field. Where did it come from? What is driving it? What is forming this magnetosphere? Well, there's two possible sources for planetary magnetism. Either it's a remnant field or the field is being created by a dynamo. And you'll see here on the screen, I'm saying remnant young, dynamo old. Remnant magnetism is left over from a planet's formation. But if you see remnant magnetism, it's young because remnant magnetism doesn't last very long. Therefore, if you still see it, the planet or the object itself is still young. It hasn't had time for that field to decay because that's what remnant magnetism does. If you want to have a magnetic field last over long, billions of years time frames, you need it to not be a remnant. You need it to be generated by a dynamo. And I'll explain in a moment what a dynamo is. For now, I'm focusing on, there's two possible sources, either remnant or dynamo, or one requires it to be young. The only way to have an old field is being driven by a dynamo. So what is a dynamo? Well, the dynamo model is fairly complicated, and I don't want to spend time on it tonight. I will just mention the basic idea behind it is that there's heat rising from the inner core of our planet, and that causes convective motion in the outer core, which is fluid or liquid. And through various complicated ways, that creates a magnetic field which sustains itself over time. So a dynamo has to be self-sustaining. The problem with this idea, and again, I'm skipping a lot of details, but the ultimate conclusion of it is that geodynamo theory for the Earth doesn't actually work. You can generate a magnetic field in a model, perhaps, of this, but it decays over time. The losses are too big. It cannot sustain itself over long periods of time. And even secular scientists admit this. As this quote says, "This problem is a serious one. We do not understand how the Earth's magnetic field has lasted for billions of years. We know that the Earth has had a magnetic field for most of its history. We don't know how the Earth did that." So if the Earth is not getting its magnetic field from a dynamo, which both models and experiments say is true, dynamo isn't going to last, and there's only two possible sources for the magnetic field. If it's not a dynamo, then it has to be a remnant magnetism left over from the planet's formation. But again, this implies the planet is young because remnant magnetism doesn't last very long. If it's still here today, the planet itself hasn't been here very long either. Furthermore, setting aside larger scale models, the Earth's magnetic field specifically shows other evidence of youth. For example, our magnetic field has a dipolar strength that is decaying. Sometimes people ask me, how long will it last? The answer is about 1900 years from now, it will be gone completely. It's because it's decaying fairly rapidly. And if it's decaying, that makes it look like a remnant field, not a dynamo, because if it's a dynamo, then it's lasted for billions of years. We wouldn't expect it to be decaying today. It's just would perpetuate itself through time, but it's not doing that. It is decaying Therefore, it makes it look remnant, which again implies it's young. Further, it's decaying fairly quickly. The half-life of this decay is about 1,400 years. So every 1,400 years, it's 1/2 of the strength it was previously. So for example, in 600 AD, which is 1,400 years ago, the field used to be twice as strong as it is today. 1,400 years before that, which is what, 800 BC, it would be 2 times 2, 4 times as strong as today. 1,400 years before that, it would be 8 times as strong as today, and so on. So you can see, looking backward through time, the nature of this decay tells us the field would have been much, much stronger, even in the recent past. Now, this is interesting because the strength of the magnetic field is related to the amount of heat inside the Earth. Is there a maximum age for this overall system? And the answer is yes. We can figure the amount of heat necessary to melt the Earth's crust. And since there's no evidence that that actually happened, that would produce a maximum age for this process. And if people are getting lost in the details, again, looking backwards in time, the field used to be stronger, which means there used to be more heat inside the Earth. But look back in time far enough, the heat or the magnetic field would have been so strong, which implies the heat was so much that the crust would have melted. That sets a maximum age for this overall system. How long ago was that point? Well, the answer is about 20,000 years. So this is an argument that the magnetic field of the Earth, and thus the planet itself, is less than 20,000 years old. Now, notice I'm not saying 20,000, it's less than 20,000, so 6,000 works just fine. Billions, however, doesn't work well at all. What about elsewhere in the solar system? Can magnetism tell us anything about age elsewhere? And the answer is yes. For example, the planet Mercury, the closest planet to the sun, very small planet. As a result of being so small, it should have cooled off after its formation fairly rapidly. Among other things, that implies that its core would have frozen solid long ago. Now, you remember the dynamo model requires a liquid motion inside of the outer core in order for a dynamo to happen. Mercury is so small that if it were billions of years old, it would have frozen solid billions of years ago. Therefore, no fluid motion in the core. Therefore, no dynamo. Therefore, no magnetic field over billions of years. But it does still have a magnetic field today. And if it can't be a dynamo, again, that implies a remnant magnetic field, which implies youth. Now, I should also mention many of the problems that I'm discussing here this evening, the secular scientists will say they have an answer for it. Like in this case, they will say, well, Mercury's core must have some sulfur inside of it that would prevent it from freezing over billions of years, thus allow a dynamo to keep operating. Yes, they do say that sulfur actually creates more problems for their model than it solves. I don't want to get into the details of answering every objection, a counter objection, everything I'm saying. I just want to mention, though, that I am aware that the things I'll be sharing that people have answers for, but I'm also pointing out that those answers don't work when you really dig into them. So we see the Earth's magnetism can't be explained by a dynamo, doesn't fit that. Mercury shouldn't have a magnetic field if it's billions of years old, but it does. Thus, it appears to be young. Oh, I should also mention, too, Mercury's magnetic field is decaying also, again, making it look very young. What about elsewhere in the solar system? Well, one of the moons of Jupiter, Ganymede, was found to have a magnetic field. And this was also a surprise to secular scientists because as a small body, should have cooled off long ago, shouldn't have a dynamo working inside of it, therefore shouldn't have a magnetic field after billions of years, but it still does. Moving farther out in the solar system, we see Saturn. Now, Saturn is, of course, a very large body, so thus we wouldn't expect it necessarily to have cooled off, quote unquote, after its formation. So in theory, a dynamo could still be operating. However, the magnetic field that Saturn has doesn't match a dynamo for other reasons. As this quote points out, Saturn first dumbfounded planetary theorists who study dynamo models by having a highly symmetric internal magnetic field. A field that is symmetric about the rotation axis violates a basic theorem of magnetic dynamos. So again, we see the dynamo theory doesn't apply or doesn't seem to fit what we see going on in Saturn. And the same is true for different reasons for the planet Uranus. Now, Uranus is a very strange planet in that it doesn't spin like a top as it goes around the sun like the other planets do. It rolls along sideways like a ball. But along with that, its magnetic field doesn't match long age expectations either. So you see here, this is a diagram of Uranus. You notice that its rotational axis is almost horizontal in this diagram, because again, Uranus is tilted way over on its side. So the equator is pointing almost straight up and down. Notice the heavy black line representing the magnetic pole. It is both tilted with respect to Uranus's rotational axis and offset from the center of the planet. Dynamo theory says that shouldn't be happening. Dynamo theory can't accommodate that. But that's how Uranus's magnetic field is. Now, again, if this is a young remnant magnetic field, this isn't a problem. But if you want to believe in billions of years and have this sustain itself for billions of years, dynamo theory can't accommodate this. Now, when this was first discovered, secular scientists said, well, maybe Voyager, which is the spacecraft that discovered this, happened to fly by the planet just as the magnetic poles are flipping, and so it looked really weird for that time. Now, that's not necessarily impossible, although it's very unlikely. The problem was when Voyager then reached Neptune, they found out Neptune's magnetic field is the same way. And so they had to conclude, well, the likelihood of us seeing both planets that just happen to be in the middle of a polarity reversal is very small. So we see that in many objects in the solar system, the magnetic fields do not match the dynamo theory. But by having magnetic fields, if they're not coming from a dynamo, that implies they're remnant fields, which again don't last long, therefore implying youth for these objects. What else can we look at when looking at things in the solar system? Well, we mentioned heat earlier. Heat is another potential age indicator in other ways. For example, let's talk about our moon briefly. Is there evidence for our moon being young? There's actually several areas of evidence. I'm not going to have time to talk about all of them tonight, but I will focus on this one. The moon is a small body. And as we already said for Mercury, small bodies cool off quickly. Therefore, if the moon were actually billions of years old, it would have cooled off long ago. And therefore, there would not be any heat to be a potential source for geological activity. Therefore, the moon should be old, cold, and dead if it were actually billions of years old. But the moon doesn't look that way. For several centuries now, it's been known that there are occasional things called TLPs, or transient lunar phenomena, which are things that happen on the moon very briefly, thus they're called transient. But they're like flashes or glows or temporary smudges that appear to the eye or even through a telescope. And they appear, they're there briefly, and then they vanish. And because you don't know where they're going to happen or when they're going to happen, no one's really been able to document these photographically. But we have observational reports going back to the 1500s. Even with the naked eye, it's possible to see some of these things. In fact, the weight of these grew so much that in 1968, NASA published the Chronological Catalog of Reported Lunar Events, which contains 579 separate entries about these temporary changes on the moon. So all of these things are consistent with the idea of volcanic venting going on the moon. These vents blow out gas. That venting might stir up a cloud of dust. There might be electrostatic discharge within that dust cloud, and then it all settles down again. Also, a cloud of dust would appear to be a smudge if it were large enough to the eye. So a lot of these things appear to be the result of volcanic activity. And there's other observations consistent with this as well. One of the Apollo missions even measured radon gas coming from the Aristarchus crater. But if the moon were old, cold, and dead, it shouldn't be volcanically active anymore. So for a long time, this was largely ignored. It was acknowledged to be happening, but no one really knew what to do with it, so people didn't spend much attention on it. But more recently, with several more missions going to the moon and making more observations, we're getting more evidence along these same lines. For example, there's now evidence that moonquakes, which are measured with instruments left behind on the moon, a lot of moonquakes are apparently associated with scarps. Now, a scarp is you see this long white line in the middle of this photograph here. A scarp is basically a long cliff. And statistically, there's a lot of moonquakes associated with specific scarps. That implies that these scarps are not just cliffs sitting there geologically inert. They're actually tectonic faults. That implies the moon's tectonically active still, which it shouldn't be, again, if it's old. Wrinkle ridges. These are formed when the moon contracts as a result of cooling. Now, if the moon were billions of years old, it should have finished cooling long, long ago. But there's some evidence that some of these ridges are still forming today. Again, this makes things look young. And a recent discovery is, in a few places, what appear to be fresh volcanic deposits. But this should have stopped happening over 1 billion years ago if the moon were actually billions of years old. And the magnitude of these discoveries are perhaps captured in this quote here, where this NASA scientist said, "This finding is the kind of science that is literally going to make geologists rewrite the textbooks about the moon. The moon does not appear to be cold and dead." Well, that implies it's not old either. Elsewhere in the solar system, we can look at heat and see if there's applications to age. For example, Jupiter has a moon called Io. You see the black dot in this on Jupiter's surface here. That's actually Io's shadow. The moon itself is a little bit to the right of that. Now, Io is an interesting little moon. It's only about 1.5% of the mass of Earth, so it's a small body. And again, small bodies cool off quickly. But Io is actually the most volcanically active body in the solar system. We've seen incredibly violent eruptions going on in Io, blasting material 180 miles into space sometimes. There's about 400 volcanoes on the surface of this small moon that have been identified, and around 150 of them are active. And they're not only violent, they produce huge amounts of material. This particular eruption produced 31 cubic kilometers of lava in just a matter of days. And some of these eruptions, by the way, think of like the size of the state of Arizona. Very large eruptions going on here. So there's a lot of heat inside of this little moon. What is the source of it? Well, if you believe in the billions of years, you have a problem. Secular scientists will tell you that Io is the result of, Io's heat is a result of tidal flexing, where Io is caught in a gravitational tug of war between Jupiter on the one side and the large moon to Jupiter on the other. And so similar to the way if you bend a wire back and forth, it heats up, this constant flexing of Io, but by being squeezed, is inducing heat into this little moon. And that's true. Tidal flexing is going on, tidal heating as a result of it. But that is not adequate to explain what we see. Io actually looks quite young. Although tidal heating is going on, it's not an adequate source to account for all of the heat. Furthermore, if that were the source of Io, the main source of Io's heat, the volcanoes would have a different distribution geographically on Io's surface than they actually do. In other words, the volcanoes don't look, or the volcanoes aren't located in the places that they would be if tidal heating was what was driving them. Furthermore, when you measure the amount of material that comes out of these volcanoes, over 4.5 billion years, this implies that Io would recycle itself through its own volcanoes, excuse me, over 30 times. Excuse me. Bad time to lose my voice. Well, that's rather abrupt. You go from voice to no voice. Let's press on and see what happens. So the amount of material coming out of Io's volcanoes, if it's been doing that for 4.5 billion years, the moon would recycle all of itself through its own volcanoes over 30 times. That does not seem like a credible thing to have happened. Furthermore, if Io were billions of years old, you would expect the high density material to settle down, and Io should have a low density crust by now, but that hasn't happened yet either. So add all this up, and Io looks very young, not billions of years old. Where else can we apply this sort of thinking? Well, Saturn has an interesting moon called Enceladus. Enceladus is actually the brightest object in the solar system, except for the sun. It reflects almost all of the sunlight it receives back into space. Now, Enceladus, at first glance, looked kind of odd. Here it is below Saturn's rings. The spacecraft was almost edge on to the rings, as you can tell. And can you see the smudge at the bottom of this little moon? Well, closer up view shows there's something going on with Enceladus' south pole. Turns out this little moon has fountains and water geysers blasting out of its south polar region at about 2,800 miles per hour. Very violent geysers. Now, what is powering this? I mean, a tremendous amount of heat is necessary to do this. Enceladus, again, a small body, should have cooled off long ago. It's supposed to be far too old to be geologically active, but apparently it is very geologically active. So what exactly is a source of energy for the geysers that we see? Well, again, secular scientists say it's tidal flexing. Gravity and interactions with Saturn and the other moons are squeezing this moon and inducing energy into it. Again, that's true. That is happening, but it's only a small fraction of the amount of energy necessary to explain what we see. Furthermore, the temperature distribution on Enceladus doesn't match the pattern that would be expected if tidal heating were driving this overall process. Now, if Enceladus is only thousands of years old, this isn't a problem. It's still cooling off after its formation. But if it's billions of years old, then there is a problem explaining the source of all of this heat. Moving farther out, we have the former planet named Pluto. Pluto was a real surprise. When the New Horizons spacecraft first got there and took our first close-up observations of this little world, Pluto has large areas of smooth, craterless terrain. You see how smooth this is, and a close-up look shows, yes, no craters. Now, apparently these areas used to have craters, because if you see this here, over on the right, you notice it's smooth. Over on the left, there are craters. And then on the boundary, there's partially filled in craters. So it appears that this resurfacing was very recent. You can also conclude that by the fact that there's no craters in it now. That means it hasn't been there long enough to get hit by impactors and form craters. In fact, the surface is so fresh that, as this geologist commented, this could be only a week old, for all we know. So Pluto is in the process of resurfacing itself through cryovolcanism. Material is coming out of the world's interior and spreading out and smoothing everything over and producing a new surface. But what is the source of heat for this process? There's really only three potential sources of heat for something like this. Number one is radioactive decay. Number two is tidal heating. And number three is primordial heat. Well, it can't be radioactive decay because we know Pluto isn't very dense. Therefore, it can't contain much in the way of radioactive material. It can't be tidal heating either, because that's not available here. It's in tidal equilibrium with its moon Charon. So the third alternative is primordial heat, heat left over from its formation. So if Pluto was created a few thousand years ago, this isn't a problem. It's still cooling off from its recent creation. But if you want to believe in billions of years, you have no source to explain the heat to drive the activity that we see. As Alan Stern, the principal investigator of the mission, said, finding that Pluto is geologically active after 4.5 billion years, there's not big enough typeface to write that in. It's unbelievable because it doesn't match the billions of years approach to all of this. There's more we could say about youth when it comes to astronomy and the various bodies we observe. But for our purposes tonight, let's move on, talk about evidence for design. When we look at the cosmos and the things within it, does it look like the result of random processes, or does it look like evidence of, just the outcome of design? Well, let's start with the object we know the most about, the Earth. I mean, we live here, so we've been studying it for the longest. Entire books have been written on how unusual and how well designed the Earth is to support life. Now, the authors of these books wouldn't necessarily say design, the first book especially. They don't believe in a designer necessarily, but they do point out how amazingly finely tuned and how unique the combination of characteristics are on this planet to support life here. Now, secular scientists say that the Earth is a result of a solar nebula, a big cloud of gas and dust, some 4.5 billion years ago. Well, that creates a problem right away, because one of the notable characteristics of our planet, especially when it comes to supporting life, is that it has a lot of water. Some 70% of the Earth's surface is covered with water. Well, that's a problem for secular scientists, because the solar nebula model says water could not have condensed out of the cloud here in our part of the solar system. It could only have done that farther out. So the solar nebula model actually predicts that the Earth had to form without any water on it, which of course is not what we see. But setting that aside, as we said, the water is crucial for life on Earth. And typically that's all that people focus on. And so you'll hear all these discussions about, oh, where we discovered these other planets, maybe they could have water on them. And if there's water, there's life. Well, no, you need a lot more than water for life. And the Earth appears to be uniquely designed to support life. For example, we've already talked about our magnetic field, our magnetosphere is very protective. It protects us from radiation from space. It allows us to retain our atmosphere too. Furthermore, our rotation period, 24 hours, turns out to be just right for life. Now, most people don't appreciate this. I mean, how many people woke up this morning thanking the Lord that he made the day 24 hours long? Because the sun goes up and it goes down and we just go about our business. But 24 hours turns out to be just right for life. If the Earth rotated more slowly, we would start to have more extreme temperature changes on our planet, because any particular point on the surface would be exposed to sunlight longer and then away from the sun for longer on the night side. And so it would get much hotter during the day, much colder at night. On the other hand, if the Earth rotated much more quickly, we would start to have violent winds on the surface. So 24 hours turns out to be just right. And we can get some perspective on this just by looking elsewhere in the solar system. 24 hours is not some inevitable automatic period for a planet's rotation. For example, Jupiter rotates all around on its axis once every 10 hours. Very short day, and implying a very fast rotation rate, especially when you consider how big Jupiter is. The opposite extreme is Venus. Venus takes 243 Earth days to rotate around on its axis once. And by the way, it also rotates backwards. So think of the range, even within our solar system, 10 hours all the way to 243 days. The Earth has a day that is 1 day long, just 24 hours, which is, again, is just right. The Earth's axial tilt gives us moderate seasons. 23.5 degrees, more or less, to the plane of the ecliptic produces the moderate seasons that we experience on this planet. And again, we don't think about this. We take it for granted. Nobody woke up this morning thanking the Lord that he gave us an axial tilt of 23.5 degrees. But it turns out to be a good value to have life possible here. And again, within the solar system, we can see perspectives of other options. For example, Mercury basically has no axial tilt. It's close to zero. So Mercury doesn't have any seasons on it. The opposite extreme to that is Uranus, which, as we mentioned earlier, is tilted way over, actually rolls along on its side as it goes around the sun. Its axial tilt is 97.8 degrees. So for portions of its orbit, one pole is pointed toward the sun and the other side is pointed away. If the Earth was like this, we would have several months where any given polar region was either exposed to the sun's radiation continually or on the night side continually cooling off, which, as you can imagine, would produce very violent climate swings on our planet. But that's not what we have. 23.5 degrees gives us just right moderate seasons. Our orbit around the sun is very circular. Again, something we take for granted, but it's not an automatic thing for a planet to have. For example, Mercury's orbit is more elliptical. Mercury actually receives twice as much energy from the sun at its closest point compared to its farthest point. Imagine if the Earth had an orbit like that. I mean, you talk about climate change. Within a period of 6 months to double the amount of radiation you're getting from the sun, we would have extreme swings in the climate here. But we don't, because that's not how the Lord made it. The Earth's atmosphere turns out to be just right. It's comparable to the thickness of the skin on a peach, if you want to imagine that. Now, that's thick enough to protect us from radiation from space and give us air to breathe, while still being thin enough to avoid a greenhouse effect. What do I mean by greenhouse effect? Well, Venus has a thicker atmosphere than Earth and a different composition of its atmosphere. As a result, Venus, even though it's roughly the same size as Earth and it's our next door neighbor in space, Venus is very different on its surface than Earth. The atmospheric pressure there is 92 times that of Earth, and the surface temperature is almost 900 degrees. So don't go vacationing on Venus, because you'd either be crushed to death or burn near instantaneously. Only a few spacecraft have even survived long enough to send a little bits of data back. It's such an extreme environment there. And that's mostly because of its atmosphere. So the Earth doesn't have an atmosphere like that. The opposite extreme is Mars, which has a much thinner atmosphere than Earth. As a result, can't retain liquid water on its surface, which is why it's a desert planet today. But the Earth isn't at those extremes. The Earth's atmosphere is just right. Now we look at all this and other things we could talk about besides and say, does this look like the outcome of random chance, of just natural processes working on materials over long periods of time? Or does it look like the result of design? And of course, I'm arguing that the Earth is indeed designed for life. And as Christians, this shouldn't surprise us because, as the Bible says, thus saith the Lord that created the heavens, God himself that formed the earth and made it. He hath established it and created it not in vain. He had a purpose. He formed it to be what? Inhabited. So if an omniscient, omnipotent, benevolent creator made the earth to support life, we shouldn't be surprised that it does that very well. Now, I've already said that entire books have been written on all the unique things the earth has to support life. What about elsewhere? The other objects don't get as much attention in this regard, but they should, because there's evidence of design elsewhere too. For example, our moon. Turns out the moon stabilizes the Earth's rotation over time. Now, this is long periods of time, as in millions of years. Doesn't matter much over thousands of years. But I think it's interesting that even if you do want to believe in the millions of years, you have to acknowledge that this would be a design feature. Even over shorter periods of time, though, there's another aspect in that the moon is actually supportive of life on Earth in the way that it raises tides. Now, the moon and the sun together raise tides in the Earth's oceans. Now, the moon is close enough to raise tides and keep ocean water circulating. And without that happening, you'd have the risk of ocean water becoming stagnant, and that would affect the whole food chain up to and including us. So the tides keep the water circulating, keep the oceans clean in a sense. But at the same time, the moon is far enough away to where the tides aren't destructive to the coastlines. So again, it turns out to be just right to serve this purpose in supporting life on Earth. It's also uniquely positioned. Its orbit and the way it lines up with the Earth and Sun means that once in a while, it will come in between the Earth and the Sun. Now, the moon is 400 times smaller than the sun is, but it's 400 times closer to us than the sun is, which means that when everything lines up just right, the disk of the sun and the moon are the same size, and the moon will pass in between the Earth and the sun and perfectly block the sun's disk from our view, producing a total solar eclipse. And these are beautiful events, awe-inspiring, well worth the time to travel to one. If you can see one, we just had one here in the U.S. recently. We're not going to have another one here until the year 2048, I think it is, and that's going to be in like North Dakota. So you'd have to travel elsewhere if you want to see one soon. Worth the trip, though, I would say. If you haven't seen one once, it's worth doing. But my point is, a lot of conditions have to all line up just right for this to be possible. Now, there's over 200 moons throughout our solar system. Of these over 200 moons, how many of them have the exact combination of size, alignment, and orbit to produce these types of events for observers on the surface? And the answer is 1. Only our moon has the proper combination of all these characteristics line up in such a way to produce a perfect total solar eclipse for observers on the planet that it orbits. And as an astronomer friend of mine says, kind of tongue-in-cheek, isn't it an amazing coincidence that the only place in the solar system where these events are observable is also the only place where there are observers to observe them? He's a Christian, of course, so he's having fun with that. Does this look like, again, the outcome of random processes? No, this looks like design. The moon indeed is designed to be the lesser light to rule the night, as the Bible says. And as I mentioned that phrase, that also brings to mind an accompanying phrase: what about the greater light to rule the day? Is there evidence for design in our sun? And the answer again is yes. For example, the sun is crucial to life on Earth, if you think about it. I mean, the sun is the source of almost all of the warmth on Earth. If the sun were to turn off tomorrow, the oceans would freeze and everything here would eventually die. So the sun is necessary to keep everything going. Further, it's ultimately the source for food. Its energy powers plant growth, and then we eat the plants and we eat other things that eat the plants. So it's powering, in a sense, the bottom of the food chain. And also in powering plant growth, it's providing oxygen for us because that's produced during photosynthesis. So the sun provides the warmth that keeps us alive, the food that we eat, and the oxygen that we breathe. So I'd say that's pretty important. Now, atheists look at this and they aren't impressed. For example, Carl Sagan said, "Who are we? What are we? We find that we live on an insignificant planet of a humdrum star, lost in a galaxy tucked away in some forgotten corner of a universe in which there are far more galaxies than people." This author said, "Our star, the sun, is rather ordinary. In many respects, the sun is entirely a run-of-the-mill entity." This author said, "Our sun, so important to us, is merely an ordinary garden variety star." Well, is the sun really mediocre? Well, the answer is no, it is not at all. For example, it's brighter than about 90% of all stars in the Milky Way, so we already see it's unusual there. It has more mass than 92%. In fact, about 75% of all stars are red dwarfs. So if the sun was a typical star, it would be a red dwarf because that's what a typical star looks like. Now, as you might gather by the name, a red dwarf is small and it's cool, thus it's red. So if our sun was a typical star, it would be a red dwarf because that's what a typical star is. Again, 3/4 of all stars are this. But we should be very thankful that our sun is not typical, that it's not a red dwarf, because red dwarfs are cool enough that in order for us to survive, our planet would have to orbit this star very closely. In fact, if the Earth orbited a red dwarf close enough to stay warm to support life, we would be tidally locked to that star. Now, a tidal lock occurs when the same side of an orbiting object always faces the thing it's orbiting. So, for example, the moon is tidally locked to the Earth. Sometimes the side that we see is lit up, sometimes it's not, but it's always the same side facing us, right? Regardless of where it is in its orbit. That's a tidal lock, and that's what the Earth would be if our sun was a red dwarf. So part of the Earth would always be exposed to the sun. The rest of it would never be exposed to the sun. And as you can imagine, life here would be very difficult indeed. Not that you'd want to orbit a red dwarf all that closely anyway, because red dwarfs are very unstable. They're sometimes called flare stars because they frequently erupt and blast material into space. And any planet orbiting close enough to be in the middle of that is not going to have a good time, as you can imagine. So again, we should be very thankful that our sun is not a typical star because red dwarfs are what typical stars look like, and we would not be here to be talking about it. But even among high mass stars, the sun is unusual. 80% of high mass stars are binary or multiple systems where there's more than one star, all orbiting a common center of mass. In fact, more than half of sun-like stars are in multiple star systems. So as you can imagine, life in a system like that would be very challenging because sometimes the stars would eclipse each other. You'd only be getting radiation from one star, whereas other times you be getting radiation from multiple stars simultaneously. So again, your climate would experience dramatic swings. The sun is a class G star, which is only about 7.5% of all stars. And even among class G stars, our sun is very unusual. For example, it's unusually quiet. A number of years ago, a 30-year study of the sun's photosphere was completed, in which they said the sun is basically constant in temperature. Over that entire 30-year period, the sun's energy output varied by less than 0.1%. Now, we don't think about that because, again, the sun goes up and it goes down and we go about our daily business. Stars don't act this way. Our sun does, but as far as we can tell, no other stars do. Even solar-type stars, which are the stars that are the most similar to the sun that we can see, even solar-type stars frequently have superflares. What is a superflare? Well, you're probably familiar with the fact that our sun is active and that it has flares sometimes on its surface. These can look very dramatic in these photographs. They're frequently accompanied by large eruptions of material, as you can see here. Compared to the Earth, you can see these are big events. Now, these are, like I said, are dramatic. Once in a while, they may affect a satellite or two on our planet, but other than that, they don't affect us much. Take one of these and multiply it by 10 million times the power. That's a superflare. Any planet in the path of one of those when they happen is in for a really rough time. And as the study found, even sun-like stars normally produce a bright superflare about once a century. Again, these are the stars most like our sun. Once a century is scarily often, if you think about it, once every 100 years for a superflare. Now, they're not always going to be in the path of a planet, but if you're rolling the dice once every 100 years, it's going to hit you eventually. But this article continues, why a superflare has not occurred on the sun in recorded history is unclear. Well, it's not unclear at all, actually. Just read your Bible. The Lord designed the sun to support life on Earth, and so we shouldn't be surprised that it does that very well without emitting things like superflares, which would contradict that purpose. See, because we tend to think of stars as these friendly little twinkly things in the sky. No, stars can be very violent. As a perspective on the potential alternatives here, this star is in the process of exploding. Any planet close to it is being consumed by that. This star is exploding in two different directions at once. This is a dual-lobed explosion. Now, admittedly, these are extreme examples, but point is, stars can be very unstable and very violent objects, except for our sun. As this author said, some of the popular perception of the sun is downright wrong. Writers sometimes tell us that it is just an average star. Not so. The vast majority of stars are smaller, cooler, dimmer, and less massive than the sun. This author said, people say the sun is a typical star. That's not true. Almost all environments in the universe are terrible for life. It's only Garden of Eden places like Earth where it can exist. I thought this was an interesting quote, given that it's the New York Times mentioning the Garden of Eden. So we look at all this and ask the question, does this look like the outcome of natural processes operating at random over long periods of time? Or does it look designed? The sun looks designed. It is unique among all the stars that we see. What about a bigger picture? Is there any argument we can make saying that the cosmos itself shows evidence of design? And the answer is yes, actually at all scales. For example, at the smallest scales, we can look even at atoms and how they interact with each other. And people have commented on how amazing and how finely tuned some of these properties are for life. For example, Sir Fred Hoyle, who was certainly no friend of creationism, said this: some super calculating intellect must have designed the properties of the carbon atom. Otherwise, the chance of my finding such an atom through the blind forces of nature would be utterly minuscule. A common sense interpretation of the facts suggests that a super intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. Now, again, he was unwilling to say who that super intellect was, but you see the point he's making. Another author said this, and you might be surprised at who this author is. He said a change of as little as 0.5% in the strength of the strong nuclear force, or 4% in the electric force, would destroy either nearly all carbon or all oxygen in every star, and hence the possibility of life as we know it. Change those rules of our universe just a bit, and the conditions for our existence disappear. Now, he's thinking of this in the context of the Big Bang model, which, of course, I don't accept. But I think it's interesting that even if you do accept it, you have to wrestle with these sorts of problems. Most of the fundamental constants appearing in our theories appear fine-tuned. If they were altered by only modest amounts, the universe would be qualitatively different and in many cases unsuitable for the development of life. For example, if protons were 0.2% heavier, they would decay into neutrons, destabilizing atoms. And since we're made of atoms, that of course would be a very bad thing. Our universe and its laws appear to have a design that both is tailor-made to support us, and if we are to exist, leaves little room for alteration. That is not easily explained, and it raises the natural question of why it is that way. So who said this? Stephen Hawking, who was a militant atheist, if you didn't know that about him. So even on the small scales, atoms, how they operate, the laws of physics at that level appear to be finely tuned. What about the largest scale? Well, you can make the same argument there. Even from a Big Bang perspective, the entire universe has extreme fine-tuning. For example, again, I don't accept the Big Bang model, but I think it's fascinating that the Lord made the universe in such a way that even if you do try to explain it without him, you have these issues to deal with. A few years back, some scientists were working with the Big Bang model and realized it's extremely sensitive to the amount of matter in the early stages of the Bang, contained in the universe at that point. In the model, there's a tension between the expansion coming out of the Bang, so the universe is expanding rapidly, while at the same time gravity is trying to pull it all back together and counteracting the expansion. So there's a tension here. And they found out that the Big Bang is extremely sensitive to the amount of matter at that point. If there was a little bit of more stuff than what the current universe has, then gravity would have won this battle. Everything would have collapsed into black holes, and you wouldn't have stars forming, wouldn't have galaxies forming, wouldn't have planets, you wouldn't have people here to look at it. On the other hand, if there was a little bit less matter, a little bit less physical stuff in the early universe, according to the model, then expansion would have won. Runaway expansion would have happened. It would have expanded so quickly that galaxies couldn't form, stars couldn't form, planets couldn't form. We wouldn't be here to talk about it then either. So when I say sensitive to the amount of matter, what's the margin of error in the Big Bang model for us to even be possible today? Now, again, the Big Bang has a lot of other problems besides this one, but even if you set all those aside, grappling with this one particular issue. Turns out the margin of error was only about, it was a fine-tuning of 10 to the 60th power. So that's just a number. What does that mean? Well, there's about 10 to the 80th atoms in the universe. And if the Big Bang, which supposedly made all those atoms, was finely tuned to 10 to the 60th power, then the margin for error was only 10 to the 20th power atoms. That's about the amount of material in a single grain of sand. So imagine not just the Earth, but the entire universe, all the stars, all the galaxies, billions of light years in all directions. Think about how much stuff there is. The Big Bang model says that if the Big Bang had made, again, the Big Bang can't make anything, but if you believe that it could, if it had made one extra grain of sand's worth of stuff anywhere in the cosmos, gravity would have won that initial battle, runaway collapse, black holes, no people. One grain of sand less anywhere in the universe than what the universe currently contains, and the opposite would happen, runaway expansion, we wouldn't be here to talk about it. So that's the margin of error in the Big Bang model, 1 grain of sand. Does that sound like a random event to you? Well, then the problem got worse. The fine-tuning in the Big Bang model is now up to 1 out of 10 to the 123rd power. That's 1 out of this number. As this author said, our universe appears surprisingly fine-tuned for life in the sense that if you tweaked many of our constants of nature by just a tiny amount, life as we know it would be impossible. Some of the fine-tuning appears extreme enough to be quite embarrassing. For example, we need to tune the dark energy to about 123 decimal places to make habitable galaxies. Again, that's just a number. What does that mean? Well, if there's 10 to the 80th atoms in the universe, but your fine-tuning is now 10 to the 123rd power, that means your precision is 10 to the minus 43 atoms. So now you're down to less than a single grain of sand. You're down to less than a single atom within a grain of sand. You're down to this fraction of the mass energy of a single atom. That's how finely tuned this random Big Bang event has to be. And of course, you see the implications of this. As this secular physicist said, this discovery is a cataclysm for physicists. And the only way that we know how to make sense of it is through the reviled and despised anthropic principle. The anthropic principle is the idea that the universe formed in such a way somehow to support human life. And you can tell what this author thinks of that idea because that implies a designer. So even if you want to believe in the Big Bang model, you have to accept that there is extreme fine-tuning going on. It does not look like a random event. Looks like it was designed. And again, not to keep belaboring the point, I don't accept the Big Bang model, but I think it's interesting that the Lord built the universe in such a way that if you do want to accept it, these are the kind of things you have to wrestle with. And that ties into our third point that I'll be making this evening, evidence for creation itself. Setting aside individual planets or stars or even atoms, is there like a principle baked into the universe itself that tells us of creation? I'm going to argue that the answer to this is yes, and it arises from something I call the secular dilemma. And it's all based on one question, simple question, 6 words. Did the universe have a beginning? Now, how many possible answers are there to this question? Well, there's only 2, right? There's either yes or no. Either yes, the universe had a beginning, or no, the universe did not have a beginning, in which case it would be eternal because it's always been there. So why do I call this the secular dilemma? Well, a dilemma is a choice between equally unfavorable alternatives. You have to make a choice, but you don't want to choose any of the options because they're all bad. Well, for secular scientists, this question presents a dilemma because we already saw, and I hope we all agree, there's only 2 possible answers, either yes or no. Both of them violate the laws of physics if you're a secular scientist. I should say just secular thinker. What do I mean by that? Well, let's look at the first answer. Yes. Yes, the universe had a beginning. Well, the universe is everything. So if everything had a beginning, what existed before the beginning? Well, the answer has to be nothing, because if something began, but there was something pre-existing, then whatever began wasn't everything, and therefore wasn't the universe. So if everything began, then before the beginning, there had to be nothing. So if you want to believe in a cosmology that has something coming from nothing, which some versions of the Big Bang model say this. Well, I have a picture of what the universe would look like before that beginning. It's this. Nothing. Of course, this is just an artist's conception. But you have to ask the question, can nothing make everything? Can you get everything from nothing? Well, can you get anything from nothing? Well, the answer is no, because nothing can create nothing. Nothing can do nothing. From nothing comes nothing. Dr. R.C. Sproul once said, if there ever once was truly nothing, there could never be anything, which I thought was a profound way of summarizing it. And like what Dr. Phil Fernandez said, he said, you can't tell me nothing made everything. I know too much about nothing. Now, so far, this sounds like a philosophical argument, but there's actually a principle in physics that formalizes this. It's called the conservation of matter and energy. An older name for this law was the first law of thermodynamics. This is based in something called, based on the equivalence of matter and energy. You might have heard the famous equation E equals mc squared. E stands for energy, and m is the amount of matter or physical stuff you have. C is the speed of light, which is a large number. So this equation tells us that a little bit of stuff, a little bit of matter, represents a lot of energy. And physics now understands there's an equivalence between the two. So this principle tells us that the total amount of matter and energy are conserved. So add up the total amount of both together, that number never changes. You can change the relative amounts of each, but when one goes up, the other one has to go down. What do I mean by changing the relative amount? Well, we can convert them back and forth. We can convert matter to energy and energy to matter. So how do we do that? Well, the most efficient way we know how to convert matter to energy is a nuclear explosion. A little bit of stuff converts into a lot of energy. We can go the opposite direction, by the way, and take a lot of energy and convert it into a little bit of stuff. And we do that in particle accelerators. You get little chunks of matter zipping around close to the speed of light, smash them together. More stuff comes out of the collisions than went in. Not just the number of particles, but the amount of matter, the amount of physical stuff. Now, are we making the physical stuff from nothing? Well, the answer is no. We're converting the kinetic energy, the energy of motion, into matter. So my point is we can convert matter to energy, we can convert energy to matter, but we can never create either one from nothing because that violates this law of physics. And it's not just a law of physics, by the way. I mean, we experience this in our daily life. I mean, if you think about it, why do we need to eat food every day? Even though that process can be difficult sometimes. Well, it's because your body needs food to get energy. Can't get it from nothing, so it has to get it from the chemical energy in the food. After you successfully get it into your mouth, which is a different problem. Why do we get bills from the utility company every month? Well, because our appliances need energy to operate. Can't get it from nothing because that violates physics. So you have to get it from the utility company, which also can't get it from nothing because that violates physics. It has to get it from the chemical energy inherent in coal, or the gravitational potential energy in flowing water, or solar energy from the sun, which also can't make it from nothing because that violates physics. It has to burn its own version of fuel, and so on. So this principle is everywhere in our lives. And in fact, we couldn't be having this presentation tonight if it weren't for this law, because some of the principles of circuit design and these devices that we're using to view this are based on this law. As one of my textbooks says, conservation laws are the guiding principles of physics. These are absolute conservation laws. They are always obeyed unless you believe in a secular cosmology like the Big Bang model that has something coming from nothing. Because if you say something came from nothing, you're violating this law on the largest possible scale. You're saying all the energy and matter in the entire universe came from nothing. But this law of physics does not allow for that. So we see everything could not have come from nothing. And by the way, this does not apply only to the Big Bang model. This applies to any secular cosmogony, any secular history of the universe, of the cosmos, that proposes that the universe had a beginning. So something could not have come from nothing. Now you may be wondering, wait a minute, there's books that say something can come from nothing and something did come from nothing. I don't want to spend time on this now. This doesn't work. If you're curious about this, ask during Q&A. We'll discuss it then. For now, I will just note, back to our dilemma, we see that the answer yes to this question, that the universe had a beginning, is not allowed by physics because that means something had to come from nothing. What about the other option? No, that the universe is eternal, basically that there's always been something. Well, let's talk about a different law of physics called the second law of thermodynamics. Now, some of you may have heard of this law, and you may have heard of the common way of summarizing, which is that entropy in a closed system will always increase. This is actually really interesting. A lot has a lot of implications in the origins discussion. But for now, I'm going to limit myself to just one aspect of it. This law has a very important implication. It's that hot things cool off. Wow, Spike, that's a brilliant statement. We're so glad we came to your presentation tonight. Well, no, actually, this is really cool because this has important implications. For example, if you walk into a room and there's a hot cup of coffee sitting there on the table, how long has the coffee been there? A long time or a short time? And when I asked this question, everybody said a short time. Why? Well, because if it had been there a long time, it would have cooled off already. Can it have been there forever? No, because if it had been there forever, it would have cooled off forever ago. So this is all driven by the second law of thermodynamics. And if we can apply the same reasoning to show that the universe itself can't be eternal. Because think about it. Is there anything in the universe that hasn't cooled off yet? Stars, right? The universe is full of things that are hot, surrounded by very cold space. If the universe had been there forever, which it would have to be there forever if it didn't have a beginning. So if the universe had been there forever, then the stars would have been there forever. The stars would have cooled off and burned out forever ago. Now, not every star will burn out. Some will blow up instead. Some meet their ends in different ways. But the point is, every star that you see is going to go away eventually. If the universe were eternally old, all of the stars would have reached their end eternally long ago. But they're still there today. Now, some people say, wait a minute, new stars can form. There's actually problems with that from a secular perspective. Setting that aside, star formation itself requires energy, of which there's a finite amount available in the universe. If the universe had been here forever, that would have been consumed forever ago, and no new stars would be able to form. So the fact that we do still see stars today tells us that the universe has not been there forever. And if it hasn't been there forever, that means that it must have had a beginning. Sometimes Christians ask, why don't we accept the Big Bang model? Because the Big Bang model shows that the universe had a beginning, and that's consistent with Genesis, and so on and so on. Well, first of all, the Big Bang model is not consistent with Genesis. My point right now is we don't need the Big Bang model to show that the universe had a beginning. If you want to prove that the universe had a beginning, walk outside and look up. Do you see the sun during the day? Do you see stars at night? If so, the universe hasn't been here forever, which means it must have had a beginning. So back to our dilemma. We saw that saying that the universe had a beginning, came from nothing, is not allowed by the first law of thermodynamics. Now we see that the second answer, that it has been there forever, is also not allowed by a different law of physics. And for the secular thinker, those were all the available options. Again, this is a dilemma. You have to say yes or no, but both are disallowed, not allowed by physics. So therefore, these two laws of physics, when combined in this way, show that any atheistic cosmogony is history of the cosmos, any atheistic model for where the universe came from is going to violate physics one way or the other, because your model has to answer this question either yes or no. And we saw that both violate physics in different ways. Now, as Christians, we have a third option. A supernatural creator outside of the universe is the only explanation that doesn't violate physics. Because if you think about it, there's really only three possibilities for the universe existing. Either it was formed by a creator, or it formed without a creator, or it never formed at all because it's always existed. We saw that the second option, forming without a creator, means something had to come from nothing on its own, which is not allowed by physics. Nor can it have always been there because the universe is not eternally old. The only remaining alternative is that it was formed by a creator. Notice, too, this is not a religious argument. I'm not quoting scripture here. This is just logic, right? I mean, those are the only three possibilities for this question. This is also, by the way, a great conversation starter. It's a simple question, right? Did the universe have a beginning? People get right away there's only two possible answers. Explore the answers with them and the ramifications, and that without a creator, you're left violating physics one way or the other. I would also say, now I can't prove this from the Bible, this is just my personal opinion. I would say this is evidence of God's grace. How many of us would struggle if there was a valid sounding naturalistic explanation for everything that we see around us? If everything around us looked like it could have come as a result of just the laws of physics operating over long periods of time, how many of us would struggle with that? I mean, the Lord could have made the universe look any way he wanted, right? He has the authority to do that. He could say, disregard what it seems to look like and trust me, I made all this recently. But perhaps he knew that many of us, and I'm perhaps even myself in this situation, would struggle with that. He didn't do it that way, though. In his grace, God placed us in a universe that looks created. The universe operates according to laws of physics that show us it was created. And I think that's wonderful. So that was the third option in our list. Just brief review. We talked about different processes and evidence for youth, different age indicators, magnetic fields, and heat. We talked about evidence for design and fine-tuning at various scales. And then we see that the universe itself operates according to laws of physics, which when applied to origins, shows us that a creator outside of the universe is necessary to explain everything around us. So this is not ultimately a battle of religion versus science. This isn't blind faith saying, ignore what the evidence is. Obviously, I'm claiming that the evidence that we see is better explained by the creation viewpoint than a naturalistic one. Science is on our side because our cosmos was created and we know the creator. Because what do the heavens declare anyway? They don't declare the glory of the Big Bang model. The heavens declare the glory of God. And this is the end of my presentation here in just a moment. Mention a couple things just for housekeeping. Number one, Jay mentioned earlier in the talk, my website is creationastronomy.com. I have a free email newsletter available there. There's a sign-up sheet at the bottom of every page. This only comes out a couple times a year at this point, so you won't be bombarded with messages. But as interesting things happen within astronomy, I publish articles there and notify you of them. I just published one a couple days ago about some new discoveries from the James Webb Space Telescope, so that's fun stuff. Also, the video series that Jay mentioned is available there, both in DVDs and in digital download form. There's a 3-volume series. Volume 1 is on the solar system. We talked briefly about a few objects in the solar system tonight. This presentation goes in depth into every planet in the solar system, many of their moons and other objects too, like comets and so on. Delves deeply into the question of origins, age, all the rest of it. Do they look like the result of these naturalistic models? The answer is no. If you like the material that you heard on this tonight, this presentation goes into much more detail. This presentation alone is about 2.5 hours. It didn't even fit on one DVD anymore. It's now a 2 DVD set. So, and as you can tell too, my preferred presentation style is very visual. I like looking at beautiful pictures and graphics and animations and videos. And so that's mostly what these things are. This one video alone, if I remember correctly, has over 600 images and graphics and videos from NASA and other sources. So very visual. Even young kids, I'm told, really enjoy watching these, even if they don't understand some of the points being made, just because we get to see some of the most beautiful objects God made. Volume 2 in that series talks about stars and galaxies. The part of the portion tonight about our designed sun is from that. It also discusses the origin of stars. Can secular star formation models explain what we see? The answer is no. What about galaxies? Are there good secular formation models for those? The answer is no. What does the size and scale of the cosmos tell us about our creator? And some other things. That's all in Volume 2. Volume 3, which Jay showed at the very beginning here, talks about the Big Bang model. Where did the universe itself come from? Is there evidence for a Big Bang? What about the evidence that is claimed to be consistent with the Big Bang? Is the Big Bang model actually good science? No, the actual answer, it's bad science because it has absurd implications, among other things, like a multiverse, that there's an infinite number of universes out there, all of which we can't see except for the one that we're in. And it also discusses the growing number of otherwise credible scientists who are claiming now that we live in an alien computer program, a simulation being run by aliens. Yes, there are serious scientists claiming this now. As absurd as that sounds, and it is indeed absurd, they have to say that because of their secular worldview going into this. They have no other choice but to do that. They don't want to accept creation, and so this is where they wind up. So that's all in Volume 3. Again, a 3-volume set. It's available at creationastronomy.com. I will also note, too, on the site, there's DVDs and digital downloads. There's another option here, which is not on the website. People who don't use DVDs anymore because it's an extinct format. All 3 videos are available in HD on a flash drive now. I only have a few of these, and so I haven't put it on the site. If you would prefer things in this format, you can send me a message through my website. Again, there's a message form at the bottom of every page, and I can send you a link to get it in this form instead. This is actually better than DVDs because DVD is standard definition, And the flash drive contains all 3 videos in high definition. So with that, I will turn it back to Jay. And I believe we can open this up for Q&A.
Sure. Well, that was an amazing presentation. I certainly appreciate that. And I, again, would repeat, those resources are very, very valuable. So if you haven't gotten them already, get all 3 and the next one, which he's working on, which he's not done with yet, but I'm looking forward to what he's currently working on. And at the end of your presentation, you just were starting to get into the Big Bang and the whole origin question, hardly even scratching the surface. We definitely want you to come back and talk about things specifically about the Big Bang, James Webb, and all those things. Multiverse, that's huge, and the implications it leads to, which I won't give a spoiler on that, but there's some interesting things that it leads to. Spike smiling, he knows what that is. But all those things we definitely want to hear about in future programs. We're going to jump into some Q&A. We got quite a few questions. There's no way we're going to get to all of them. I'm going to start going down the list, throwing out one at a time and see how many we get through in the remaining time that we have. I'll start out talking about one that was mentioned early on in the program when we were talking about the Earth's magnetic field and its decay and its, rough half-life of about 1,400 years. The question is, how do you arrive, when they say you, not specifically you, but how have scientists arrived at the idea that its half-life is 1,400 years? You could tell us a little bit about that.
We've had good measurements of it going back to the 1800s. So by observing the decrease in the dipolar strength over time, and by plotting that out, we see it's a decaying curve. And so you extrapolate that, and that's how you reach the half-life. Now, of course, we haven't been measuring it for that long, but we have well over a century of data now, and some good measurements along that. So that allows us to reach that conclusion.
Sure. And just an ancillary point with that too, the half-life decay indicating an upper limit for the age of the Earth. Sometimes people will say, well, that's assuming it was constant, but we kind of laugh because we're saying you're the ones who say that we should assume that what we see today is what has always existed. So
right.
As creationists, we say, we don't think that's the best assumption, but we'll give you that. Even if you do make that assumption, you got problems. And then you apply their assumption to all these different methods, like the decay of the Earth's magnetic field, and they got problems. So
it's an excellent point. Yeah.
Sure. Next question, kind of off the board, but a lot of people are interested, and so you can comment on it. We won't probably talk too long about it, but the question is, do you think we have actually walked on the moon?
Yes. I haven't. Wish I had. Not many men have done so, but yes.
Yeah,
several of the men who did that are Christians, by the way, and have, and are very open about their Christian faith and testimony.
Sure.
So it's not merely, if you're saying that it didn't happen, you're not merely saying there's this conspiracy to do this fake thing. You're saying that these men are liars. And I don't see any evidence that, I was only 3 years old when the first landing happened. I'm showing my age here. It's actually my first memory was the Apollo astronauts on the moon. It was that big of an event. I don't see any reason that it would have been faked. I don't see any evidence that it was faked. And there's so much evidence that it actually happened that I don't have a problem asserting that it did.
Sure. I also actually heard there's a new restaurant on the moon. They say the food's pretty good, but just no atmosphere. Bad joke. Sorry. Had to throw that in there before we move on. Sorry. I'll never be host again, probably. Next question. What do you think about the expansion of the universe? Do you believe we can actually assess the distance of faraway galaxies?
Okay, so the expansion of the universe is the conclusion of observed redshifts. So as we observe objects that are farther and farther away, their light is more and more redshifted. The most, how to word this? The most common interpretation of that is an expanding universe. Now, there are other interpretations. I'm not going to assert one or the other currently. This is a big rabbit hole to open up. But saying that it's evidence of expansion, I don't have a problem with anyway. It doesn't necessarily mean expansion is happening today. It could be the evidence of previous expansion during creation week. There's different ways for us as Christians to even look at it, even with the context of it being expansion. There are people who have said that the redshift may have at least some, if not all, of a non-expansionary explanation. Again, I don't want to open up big cans of worms here because I'm not sure how really fruitful this would be anyway. I don't have a problem with the universe expanding. The Bible says in some 17 different places that the Lord stretched out the heavens. Maybe that's just poetry, but maybe he's telling us that's what he actually did. That doesn't mean it started in a big bang all by itself. It could just be part of the Lord's creative handiwork. As far as accurately assessing the distance of galaxies, of course, the farther out you get, the errors get a little bit bigger. But we're still talking large distances. We can directly measure distances much farther out than 6,000 light years at this point. So if the main question is, how do we know all this stuff is really that far away and how old it all is? We have a variety of methods. Close by objects we can measure directly. Farther out from there, we use the close measurements to calibrate the farther out techniques. There's a possibility of error being introduced along the way so that at the farthest distances, maybe there's 10% error. But even 10%, you're still talking billions of light years of distances. So yeah, I don't dispute the fact that these objects are indeed very far away from us. That's the motive for that question.
Sure. Okay, next question. Jupiter is assumed to serve a purpose of deflecting comets away from the Earth as the Earth's protector of sorts. What could be a purpose of tilts and other properties of other planets and their moons?
I think a lot of the things we see in the solar system, maybe this is like a chronological chauvinism. I think some of it is to provide us a perspective today in our technological age of the alternative. If the Earth were the only planet in the solar system, then we would just kind of assume that this is how a planet should be, with the atmosphere and the axial tilt and the rotation period and the mass and all the rest of it. You wouldn't have anything to compare it to. But like our rotation period, 24 hours, turns out to be just right compared to 10 hours on the one side versus 243 days on the other. Looking at all these other things within the solar system gives us a perspective as to how wonderful our planet actually is and how well designed it is to have us here on it. So that's my personal opinion. The Bible doesn't go into that level of detail. It just says that they declare his glory. I think that's one of the ways in which they do that.
Sure. What about, I'm going to just throw one of my own random comments here about Venus and Uranus and their different rotational properties. To me, it almost seems like God says, watch this, meaning like, try to explain this from a nebular hypothesis. So maybe comment briefly on why those are a problem for the nebular hypothesis. Yeah,
each planet within the solar system causes problems for the nebular hypothesis in a different way. And that's the first volume in my video series goes into in great detail. So yeah, it's a fun exercise because each one does it in a different way. And some of the ways are linked in a sense that if you change your model to explain this one, the other one gets worse. So I think that's a lot of fun.
Sure.
We don't know that the Lord did it for that reason, but we can speculate. And
okay.
Yeah.
Another question. This one's very interesting. Could we be in a young solar system, but which is itself in an old universe?
Well, I would ask the question as to why you would want that. What is your goal in making that? I've had a conversation a while back with I believe he's a theologian who is proposing this. There's in Genesis, day 4, it says the Lord made the greater light to rule the day, the lesser light to rule the night. And then a lot of translation says he made the stars also. That phrase, he made the stars also, is actually only 2 words in Hebrew. It's ve'eta kochavim, if I remember correctly. So, and the stars, 2 words. And the word and is preceded by a particle in Hebrew called et, that doesn't have an equivalent in English, but it's the marker of the definite direct objects. So in English, we say he threw the ball. In Hebrew, you would say he threw et the ball. The et tells you that the ball is receiving the action of throwing. And the structure of that verse in Hebrew is actually one continuous sentence. It says, he made et, the greater light to rule the day, and et, the lesser night to rule the night, the lesser light to rule the night, and et, the stars. It's a continuous thought. Even though, like I said, a lot of English translations break it up in a separate sentence, it's not that way in the Hebrew. So the stars are included in what happened in day 4. So the stars did not pre-exist day 4. Day 1, 2, and 3, there was the earth and nothing else was spoken of. And then on day 4, you have the sun, moon, and stars being formed. So I don't see how you can propose that all of this other stuff existed when the grammar is structured that way.
Sure. Yeah, it certainly doesn't seem to fit in with the text. I think a lot of Christians just feel so pressured to accept an old universe, and then they try to fight it like, well, maybe the earth is young, but the universe can be old. And, it's an interesting thought, but I hope it drives them into actually studying the scripture first and foremost. And then they find out later that science doesn't really support it anyway. They shouldn't feel that pressure to try to squeeze it into scripture. Next
There's
question.
also the passage in Mark where Jesus said, from the beginning of creation, God made them male and female. If you're going to say that everything but the solar system existed, I mean, like that's basically everything other than this little minor solar system in this vast cosmos was there for billions of years first. That doesn't really seem to me to fit what Jesus said there. Yeah. From the beginning of creation.
Mark 10:6, Matthew 19:4. God started the Pharisees who supposedly knew the Old Testament scripture and says, haven't you read? Almost seems like there's some sarcasm. Like, I thought you were the guys that knew scripture, but haven't you read that he who created them male and female from the beginning of creation? That only works with the literal 6-day creation.
Right.
All right. Next question says, external to the solar system, so possibly off topic, but some people associate the surface of last scattering with the point at which God separated light from darkness. Any comment?
That's approaching things kind of through a Big Bang lens, which I would not do. So I'll just leave my comment at that, because most people probably don't know what the question means anyway. So we'll be merciful to the rest of the audience.
Okay. Another question, kind of deep. Energy has a frequency, thus data and information. Spooky entanglement implies that we are connected to that information. Does creationism break with spooky entanglement? That's actually
you're picking all the fun questions there, Jay.
Yeah.
Entanglement is based on the Copenhagen interpretation of quantum mechanics, which not everybody accepts, even on the secular side. It's certainly the consensus viewpoint among the majority of scientists, but it's not the only option on the table. It also has philosophical problems because it says something doesn't exist until an observer observes it and forces it to resolve into one state or the other. Well, the observer themselves is part of the physical system, so the observer can't exist until another observer observes him. Well, then who observes that observer? You have an infinite regress problem. So to my way of thinking, the Copenhagen interpretation has a fatal flaw in that aspect alone, just setting aside all of the other weirdness associated with it.
Sure.
So without going down this rabbit hole too far, I would say the question arises from an interpretation of quantum mechanics, which is not the only interpretation that's available.
Yeah. And, a comment is a lot of that stuff is so theoretical. It's fascinating, but a lot of it we could probably never really, really know. So we shouldn't get too hung up on it. Some people spend their whole life studying one thing, and then they find out before they die, oh, I guess I was wrong. And someone takes over and goes a different direction with it. So it's interesting to think about, but we shouldn't be pressing it too hard to try to make it fit something, because it'll probably change quickly anyway.
Good point.
Here's a more basic question. What precisely is gravity? Since the physicists don't have the answer, I'm not going to hold my breath for an answer.
Gravity is understood to be a distortion of space-time caused by mass. Now we experience that as a force, as if things are being attracted together, but that's what current physics tells us is happening under the cover, so to speak. If you want to go any deeper in that, then that's where the head scratching begins.
Yeah.
The other forces within physics, there's the theoretical framework that they all fall under. Gravity still remains apart from the rest. and has been the result of intensive study for decades now, and in some aspects isn't any closer to a conclusion. So
Sure.
good question is the answer.
Yeah. Interesting. Stephen Hawking also had to answer, how do you get, something out of nothing? And he said, because there is a law such as gravity, that your universe can and will create itself from nothing. It's like, wait a minute. He said there was something, the law of gravity, so the universe can create itself from nothing. Well, if you have something, you don't have nothing. And what was the nothing or something he mentioned? The law of gravity, which is really a description of how they think the universe operates. It isn't something that can create a universe out of nothing. But
yeah, a law of physics is just a pattern of behavior for the universe that we've recognized. Before the universe existed, there was no behavior of the universe and thus no patterns.
Okay, here I'm getting my question list is bumping around a little bit. I got to find one here. Question: I have been searching for a clear answer as to why we find craters on the moon and Earth. Is there a good biblical or creationist explanation to the existence of craters?
Craters are mostly the result of impacts. So something flies in from space, hits it, and forms a crater. Often you'll have multiple craters formed from a single impactor, depending on the angle and the speed and the size and all the rest of it. But yeah, for a while, this is early on when people were really starting to study these things, some people wondered if the craters on the moon, for example, were all just volcanic vents, because people said, well, the craters are all circular, and if they're the result of an impactor coming in at an angle, wouldn't it be more of an oval? Well, the answer turned out to be no. The energy from the impact turns out to distribute itself evenly so that you wind up with a circular crater, regardless of the angle and so on. So yeah, the craters are just a result of impacts of things coming in from space. And we've seen some being formed, incidentally. There are examples where we've witnessed impacts on the moon, and then here's a new crater that wasn't there before. So,
okay, good answer. Here's one that I'm sure a lot of people will benefit from hearing the answer to, and you and I have discussed this at length. What exactly are dark matter and dark energy?
Oh boy. Despite the names, they are not similar. They're not related. So dark just means we don't know what it is. And we can't see it. So that's what dark indicates. Other than that, these two things are unrelated. So dark matter is a proposed explanation for the behavior of stars within galaxies and galaxies within galaxy clusters. There appears to be, how to summarize this in a short way. On the outermost regions of some galaxies, stars are going at a speed that they should not be going if our understanding of orbital physics is correct. One possible explanation to make them do that is a distribution of matter outside of that galaxy, like a halo. The problem is that we don't see any matter there. So a proposed explanation is that there is actually matter there that's affecting these stars gravitationally and making them behave this way. But the reason we can't see the matter there is because it's invisible. So dark matter today is a proposed explanation where there's this stuff, it's physical matter, but it's invisible to us because, unlike ordinary matter, it doesn't interact with light. It interacts with other things only through gravity. So light would just pass right through it. It doesn't emit light. It doesn't absorb light. It just doesn't interact with it at all. We don't know of any particles within physics that will do that. There's been different ideas. Nothing has really panned out to this point. So dark matter is one proposed explanation for otherwise anomalous behavior of stars within galaxies and galaxies moving around within galaxy clusters. Another option is that we don't understand orbital physics correctly on such large scales. And there are people pursuing that option as well. So they are addressing the same anomalies without proposing exotic new forms of matter, i.e. dark matter. So that's what dark matter is. Dark energy is something required by the Big Bang model. If you interpret, people mentioned expansion earlier, if you interpret the redshifts and evidence for expansion through the lens of the Big Bang model, you are forced to conclude that not only is the universe expanding, it's expanding at an accelerating rate. So the rate of expansion is getting faster and faster. that requires the universe to be filled with basically anti-gravity energy of some sort. And since that's completely unknown to physics, but the Big Bang model requires it to exist, they've assigned it this name, dark energy. So you will be told that dark energy is this thing that permeates the universe. In fact, it makes up about 3/4, roughly, I don't remember the current number, of the total mass energy of the universe. So most of the universe is this mysterious anti-gravity force that we otherwise have no explanation for, other than the fact that the Big Bang model needs it. Now, I don't find that very satisfactory. A lot of other people don't as well. Not only is it anti-gravity energy, which sounds strange enough in itself, it has to be constant per unit volume of space. And since it's forcing the universe to expand, it's creating more space, each cubic meter of which contains the same amount of dark energy as the previous stuff did. So not only is dark energy driving the universe to expand faster and faster, it's creating more of itself as it does that. Which obviously is a very strange concept and has no basis in physics otherwise, other than you need it to solve certain problems of the Big Bang model. So this is one of the things which many people would view as sort of a band-aid for the Big Bang model. There's something that it can't explain, so we'll just invent a new form of matter or a new form of energy that's otherwise completely unknown to save our model from being disproven by the evidence. That's probably a really harsh thing to say.
Well, but you'll be backing that up a lot more when you talk in the future more about the Big Bang, how it's basically on life support just because they don't have anything else to replace it. And if they do find something, they'll drop the Big Bang so fast it'll make your head spin.
Probably.
Sure. Another question. Do you have a theory as to why our creator made such a large universe? Is it simply for our research, or do you think that he may have created life in other places as well? Just one quick comment, and then you can answer that. I sometimes humorously say, I think God had to spend all of his energy just to make it this size. He had to hold himself, use all of his strength to hold himself back to only make it this big. I mean, he's an infinite God, infinite in power. And sometimes I say, would a smaller universe have done a better job to reflect his glory? As big as it is, people still reject him. So would a smaller one have done better? But you can go ahead and respond to that.
Yeah, I think I mentioned earlier in the presentation, the size and the scale of the universe tells us of God's power and majesty. Not only its size, but by the way, but also in our ability to observe it. If we were like in the arm of the Milky Way galaxy instead of between the arms, which is where we are, or if we were at a different location, we wouldn't be able to observe into the deeper cosmos because we'd have stars in all directions blocking our view. So not only did God make this amazing large universe that we can look in all directions and just be awestruck by what we see and the size of everything, but he placed us in a specific place where we have the ability to observe that. Its purpose, I think, is to demonstrate his power, to fill us with awe. I think that's a valid reason. I privately speculate that maybe once everything is, once the Lord comes back and everything is different, will we get to explore? I don't know. I hope so, but that's pure speculation, obviously. I don't know. I mean, atheists interpret it as proof of our insignificance. That, there's this vast universe where basically, a rounding error in the greater scheme of things. Lawrence Krauss said we're basically a bit of pollution. If we were to disappear, it wouldn't matter at all. Well, the Bible tells us the opposite is true. The earth is the center of God's attention. Christ became a man and became one of us, despite being the creator of all that we see in the cosmos, as John chapter 1 says and elsewhere. So I think it's not only to demonstrate his majesty and power, but also the depth of his love. Were it not for the universe, I mean, we still can't fully appreciate God's glory anyway, but the size and scale of the cosmos gives us a glimpse rather of the depth of his love, in that his son took on human flesh just to redeem us from our sins. So I think this touches on redemption as well.
Sure. No, great answer. We'll do two more. We've gone a fair amount of time for Q&A, but great questions. We'll do two more. One it has to do with the God particle. Can you share briefly your understanding and opinion of Higgs bosons and Higgs fields?
The Higgs field was just the proposed field that would explain mass. And it was something that was predicted within particle physics and then verified in particle accelerators. And so that was an example of a good physics prediction that was upheld by experiments and shown to be correct. The more interesting aspect to me is not, I mean, calling it the God particle, that was something in the media that was frankly silly. That had nothing to do with, I mean, it's just physics. The more interesting question for me is what happens after the Higgs has been verified. There were a lot of theories constructed about supersymmetry and some other structures that people wanted to find within particles to explain away what otherwise looks like a lot of design and fine tuning. And those theories have not been upheld by experiment. And I hate to mention this because I'm just touching on something that would get people curious without the time to explain it. But after the Higgs was verified, subsequent things that have been looked for have by and large not been found. A lot of those things were efforts to explain away apparent design and apparent fine tuning within physics. So that to me is the more interesting aspect of particle physics, not so much about the Higgs, but what came afterwards. And the discrediting a lot of the secular motivation theoretical frameworks that have not been found, that have not been, I should say, upheld by experiments.
Good. Well, we'll wind down for now. Again, many other topics we could cover with you, but we'll save some for future broadcasts. Last question is going to be, does the sun have a magnetic field? If so, what causes it? And how would a star's magnetic field differ from a planet magnetic field?
The sun does have a magnetic field, and they're generated within stars. Magnetism is generated a bit differently than planets because a planet has an inner core and outer core, a mantle, and then a crust. And the crust doesn't tie into this. It's mostly the core driving this process. The sun has nuclear fusion going on inside of it, and so that, of course, is doing all sorts of other things that a planet doesn't have going on inside of it. I'm not an astrophysicist, so I know the rough outlines of how this is supposed to work. It's a very complicated thing and very much ongoing areas of research. If you poke around YouTube, you'll find videos of some really cool stuff that's been captured going on the surface of the sun. So like you have sunspots coming and going, you have fountains of material coming up and raining back down, bubbling and boiling and erupting, and also it's a very active thing going on. And a lot of that is due to eddies and currents and other things going on with, currents is the wrong word, but eddies going on within the magnetic field of the sun. So the rough outlines of how this is driven are understood. All the details of how something on that scale works itself out. And so you have all these local effects, again, some of which are just beautiful just to watch. That's still very much an ongoing area of research.
Sure, great. Well, we will wind down. Thank you, Spike, for all that great information. This was a warm-up for those of you watching. A very general introduction to astronomy. He's kind of teeing it up to go a little bit deeper on some of the other specific topics, with Big Bang and multiverse and maybe life in outer space, whatever we cover in the future. I'm looking forward to that. So as a reminder to everyone listening, make sure that you check out Logos Research Associates website to see different research projects that are going on, who's involved with the group, learn more information if anyone's interested in becoming part of the group. If you have the proper background for that, contact us. We can talk to you about that. Also consider supporting some of these ongoing research projects that we have. There's a lot of great cutting edge research happening, and it doesn't happen in a vacuum in a sense. So we definitely need funding for that. So learn more about the projects from the website. Also sign up for our email list. You can be kept abroad of what's going on. And if you sign up for our email list, you'll also receive the Creation Evolution Headlines newsletter. That's a great resource for all the articles that are coming out in the publications and commentary on these things. It's just a great, valuable resource. So you get that.
Yeah, I'd highly recommend that one too, by the way.
Yeah, it's amazing. And then also, recording of this program will be available through logosresearchassociates.org website. So it'll be archived, and you could forward it on to other people or rewatch it if you want to hear Spike's presentation again, and give it to people who were not able to join us live or tonight. So our next presentation will be, it's up on the screen, Wednesday, August 14th, 9 p.m. Eastern time, same time that this one was. Sarah Peterson, PhD geophysicist, has worked with Dr. John Baumgartner. She's going to be presenting something called Tectonic Changes Within Western North America During the Flood. Tectonic plate activities, very detailed. She's done some fascinating research, and you'll learn a lot, especially as it relates to North America and the flood itself. So definitely want to put that on your calendar. And you, again, if you sign up for our newsletter list, you'll be alerted when that broadcast is coming out as well. And again, make sure you tell other people, because we want to get this into the hands of as many people as possible. We got so many great research scientists diving deep, but then kind of paring it down to a level that most of the rest of the world can understand, and all with the idea of supporting the biblical narrative. You can trust the Bible cover to cover, even though it gets attacked so much from the secular scientific community. But the more we study science, the more we realize the Bible got it right from the beginning. And even though the Bible's God's first shot at writing a book, I think he did a pretty good job. And we just need to be patient with the secular scientists for them to catch up with God's word. So I will close in a brief word of prayer, and we look forward to seeing you at our next broadcast. Dear Heavenly Father, we just thank you again so much for this time. We thank you for Spike and his presentation and all the research he's done over the years that we can benefit greatly from. We're looking forward to hearing from him again in the future. We just thank you again for the graciousness and the patience you show to each one of us each day. And I pray that you would be working in the lives of all those Christians hearing this message to better position them to go out and not win an argument, but to more graciously and more powerfully share the gospel message, knowing there are answers to the tough questions that come up. And then for anyone watching, God, who isn't quite there yet, kind of on the fence with this whole idea of God and the Bible and Jesus Christ, I pray that these presentations would give them something to think about and give them reasons to consider the validity of your word and ultimately come to a personal relationship with you through Jesus Christ. And we just pray all these things now in Jesus' name. Amen. So thanks again, Spike, and everyone else.
Thank
We
you, Jay.
will see you guys next
Thanks, everyone.
time.